We will finish today's lecture by talking about Lewis structures, which represent a convenient way of keeping track of electrons, which of course is something that we do not want to lose track of in chemistry. And so I think the easiest way to look at this is simply by analyzing some examples. One of them is methane. And this is a molecule which has 4 covalent bonds between carbon and hydrogen. Carbon has 4 electrons. Each of the hydrogens has 1 electron. So it's a total of 8, and you see all 8 electrons here. And this molecule is called methane. Now all of these electrons are shared. These bonds are covalent but polar. And this is a Lewis structure, Lewis dot structure of methane. But drawing all these dots gets a bit cumbersome after a while. And so a convention which is often used in chemistry is that 2 dots equal simply a line which connects the bonded atoms. And so in that convention, our picture of methane would now look this way. And this is called simply the Lewis structure. A higher example could be a molecule which has 2 carbon atoms, which is called ethane. Now remember, each carbon atom here has 4 electrons, 4 valence electrons, so that's a total of 8 for 2 carbons. And there are 6 hydrogens here, so that is 6 more electrons, and 8 plus 6 is 14. So there's 2, 4, 6, 8, 10, 12, and 14. So they're all there. And again, using our convention, we transform this into this structure. Now from these 2 simple molecules, it's already apparent that hydrogen can have only 1 bond to it, because it has only 1 electron that can share. Whereas carbon can have only 4 bonds to it, no more nor less, because it has 4 electrons that it can share. And these are, with very, very few examples, rules that apply always. Okay? Now, not necessarily all electron pairs have to be shared. So some electron pairs can stick with their host atom, and they're called the non-bonding electrons. Carbon rarely has non-bonding electrons, but elements like nitrogen or oxygen often do. In actually most of their compounds, they do have non-bonding electrons. So here, this is a compound known as methylamine. It has nitrogen with 1 free electron pair, which is non-bonding. Compound known as methanol has oxygen, and oxygen has 2 free electron pairs. And here in one more compound known as chloromethane, there is chlorine, which has 3 electron pairs. And these rules are pretty general. Nitrogen in most of its compounds will have 1 non-bonding pair of electrons, oxygen will have 2, and chlorine and other elements, other halogens will have 3. Even when we use these lines to draw the Lewis structure, we will still use the 2 dots to represent the non-bonding electron pair in order to make it look different. So we want to explicitly draw the non-bonding electron pairs. In counting the electrons, we can again see that oxygen has 2 electrons shared with carbon, 2 electrons shared with hydrogen, so that's 4, and then 4 of its own, which makes 8, and that is again the stable octet configuration. Now, 2 atoms can share more than just 2 electrons. and carbon is a very prominent example of that. So if you look at this compound, which again has 2 carbon atoms but 4 hydrogens, we will see here, and this compound is called ethene, that 2 carbon atoms share a total of 4 electrons. And so according to our convention, this molecule will be drawn this way. And this thing here is a double bond. And there's nothing unusual about it. In fact, things can get even more strongly bonded. The molecule shown here, called acetylene, which is perhaps familiar to some of you through acetylene torches. Any one of you knows anything about welding. And this molecule basically has single bond between carbon and hydrogen, and then triple bond between the 2 carbons. So this is now a triple bond. But notice again that hydrogen always has 1 bond to it, and carbon, in this case, has 1, 2, 3, 4 bonds to it, and in this case, 1, 2, 3, 4. So the 4 bond rule always applies. Other elements can form multiple bonds as well. This is an example where carbon and nitrogen have a triple bond between themselves. And this molecule is known as hydrogen cyanide. And it's an extremely toxic gas. Okay? And this structure nicely highlights a lot of things that we talked about. It highlights the triple bond, so the multiple bonding. It highlights that hydrogen has 1 bond to it, that carbon has only 4, and that nitrogen in most of its compounds has this 3 electron pair. Now, next time we will continue with some more structural representations, and it's important that these structural representations become very, very fluent for you, because they're used almost mechanically in chemistry as we get into more advanced concepts, and so it's important to be very proficient. Thank you.